Jai Hind students. Now we are going towards the end of this unit, and in this particular lecture of satellite communication, basically we are going to focus on the various advantages and disadvantages of satellite communication. Before that, I want to once again tell you about the satellite communication so that you can easily understand the pros and cons of satellite communication. That in satellite communication, basically we are sending an object in the outer orbit of the earth, and basically that satellite is revolving around the earth in that orbit. So that particular satellite is used for the communication purpose, and that communication is related to long range communication. As you already discussed that ground wave, space wave, sky wave propagation, the communication is limited between around 1500 kilometer range, because for the greater than 1500 kilometer we did not get the line of sight communication on the earth. That's why satellite communication came into the picture. So in this particular part, you can easily understand that the earth station is sending the data to the satellite on uplink frequency, whether the satellite is sending the data to earth station on downlink frequency. These all points you already discussed in the previous sections. We also studied about the various kind of satellites on the basis of various things, such as the height of satellite in the orbit, or we can say that the altitude of the satellite. As per that, we understand that there are many types of satellite possible, such as lower earth orbit satellite, medium earth orbit satellite, geostationary orbit satellites. Other than that, as per the weight, we have some small satellites, large scale satellites, and medium scale satellites is also. So as per these all points, we decided the various use of satellite communication, and as per the uses of satellite communication, we decided the various satellite services, communication services. That was fixed satellite services, broadband satellite services, radio navigation satellite services, radio determination satellite services. So as per all that services and the frequency allocation for the frequency satellite communication, which was decided as per the L, S, C, X, KU, K and KA bands. Basically, for the satellite communication, we are taking the frequency band of 1 to 40 gigahertz. In that particular band, the LSC bands are used for the domestic communication purpose, where X band is used for the military or intelligence purposes, whether the KU, K and KA, that is stand for the K under, K and K above, that bands are used for the extraterrestrial communication purpose, for the deep space missions. So as per these frequency allocation and the various types of satellite services and the types of satellite, their launching procedure, we have some advantages of satellite communication. So first one is that area of coverage. Basically, area of coverage is more than that of terrestrial system. As I told you earlier in the starting of this syllabus, that in terrestrial system, we are using the sky wave or ground wave communication or ground wave propagation, and for sky wave or ground wave propagation, we are limited to only 1500 kilometer. But when we required the communication more than for the 1500 kilometer range, so we require this satellite communication, and the satellite communication give us the a more area of coverage for the terrestrial system. Then second point is each and every corner of the earth can be covered. As I told you, to cover the complete earth, we required 3 geosatellites. I told you this about in the first part of the types of satellite, that by using 3 geosatellites, you can cover the whole earth. So, by using this satellite communication, the main advantage is that you can cover the each and every spot on the earth wherever it is located. If we are using medium orbit satellite, then it will increase, that is around 8 to 20 satellites. But when we are talking about the lower earth orbit LEO satellites, that is about 20 to 60 satellites for the covering complete earth. Then transmission cost is independent of coverage area. As when we are installing the ground wave or sky wave propagation units, we required many repeater circuits between the transmitter and receiver. Each repeater circuit required some initial costing for the installation. So, as far as this use of repeaters are increased, it means the coverage area increased, the number of repeater increased. That's why the total cost is also increased. But when we are talking about the satellite communication, as I told you, 3 geosatellites are sufficient to cover the whole earth, each and every part of each and every corner of the earth. That's why you are initially giving only cost of 3 geosatellites, and that is going to complete the complete earth. That's why the transmission cost is independent of coverage area. Also, the more bandwidth and broadcasting possibilities, as you can use all the data, all the systems at the same time with the multiple access techniques and multiplexing techniques with higher bandwidth range, and that lies between the 1 to 40 gigahertz range, you can easily increase the advantages of satellite communication. But there are still some disadvantages of satellite communication, and very first disadvantage is launching of satellite into the orbit is a costly process. As you know that in the recent years, the launching of satellite is quite increased throughout the earth, and in this complete process, we required a well established system or well established process we have to follow to launch a satellite into the earth, and that complete process required a very sophisticated and large infrastructure for the launching purpose with very specific parameters. So that's why the complete launching procedure is quite high. Then the second disadvantage is propagation delay of satellite system is more than that of conventional terrestrial system. Actually, when we are talking about the conventional terrestrial system, the propagation delay is increased as the signal is transmitting from earth station to the satellite and coming back from the satellite to earth station. That will cause a propagation delay that is more than the sky wave or ground wave communication. Then the third disadvantage is difficult to provide repairing activities if any problem occurs in the satellite system. This is also a very major problem because your satellite is actually placed at a remote position, and when you are putting it on a remote location, you cannot repair it whenever it is required. So that is also a very big problem for the satellite communication purpose, as if you are going to face any type of issue in the communication, you have to replace that particular satellite, or you have to relaunch some other satellite to take the place of the previous one. That's why this initial costing will also increase, as you can take the example of Navik. Navik is basically navigation for Indian constellation, and that particular navigation for Indian constellation having the 8 satellite in the space launched by the India for its O1 GPS system, and in that particular system only 6 satellites are basically using for the communication purpose, and the remaining 2 satellites are acting as a standby satellite whenever or in any case you are facing any error or any problem or any type of technical error in the satellite communication of a particular satellite, then that particular standby satellite can take over the charge of that satellite. So it means you always required some kind of backup plan in the case of specific kind of errors. Then free space loss is more. That is also a point. That's why we designing the uplink and downlink frequency as per the free space losses, because as per the earth atmosphere layers, as well as you are increasing the high altitude, that free space loss is also increasing, and also there can be a congestion of the frequencies as you are using 1 to 40 gigahertz frequency range, and that 1 to 40 gigahertz frequency range is almost used by the all wireless communication units. That's why there may be a chance of congestion in the frequencies. So these are the basic advantage and disadvantages of the satellite communication. Then the satellite communication application. As we discussed various type of satellite and studied various type of satellite system, now these all are the basic communication application of the satellite communication. Other than these applications, some more applications are there, but these are some key application of satellite communications. First one is radio broadcasting for the radio communication and voice communication. TV broadcasting for the various channel you are going to get on your TV set by using the direct to home technology. Then internet application such as providing internet for the providing internet connection for the data transfer, also that GPS application, and I told you earlier that the NAVIC, that is Indian navigation for Indian constellation, that is our Indian GPS system, also for the military applications and navigation, remote sensing application, and the weather condition monitoring and forecasting. So these all are the basic application of satellite communication. Now we are going towards the next very important part of the satellite communication, that is satellite life cycle. Basically, when we are talking about the satellite life cycle or satellite life phase, it is basically taking the main steps to design a satellite as well as launching the satellite in the space and the monitoring of satellite in the particular orbit. So basically how it is going to start. So first of all, the scientist or the research team which is going to make a satellite communication system, first of all they are going to decide the purpose of the satellite communication. It means either you are using that particular satellite for the radio broadcasting or the TV broadcasting or for the internet application. As per that purpose, we are going to decide the particular satellite aim or object for which we are going to design that particular satellite. Then second point is budget. As cost is always a major part for any company, first of all budget is decided, and that budget is assumed, or we can say that that budget is calculated on the specific parameters of the satellite requirement, its launching cost and another things. Then the third point is orbital allocation and the traffic management. That traffic management is a very important part that I am going to discuss in the next slide basically. Before that, orbital allocation. As you know that from the starting of the satellite communication in 1957 by the Sputnik, right now there are thousands of satellites located in the Earth outer atmosphere, and that all satellites are creating a very bulky environment. You can see in this diagram. This was the starting picture in the 1957, and right now in the around 2020 you can see that this is the actual condition of the space. You can easily see that in condition there are various objects in the particular in the outer space of the Earth, and that are basically creating a very meshy structure. And before launching any new satellite, it is required for any satellite communication unit to decide the particular orbit for that satellite. that orbit is actually identified by the purpose of the satellite. Basically, if you are using the particular a specific area coverage satellites, you are going to use the HEO satellite, that are hyper elliptical orbit satellites. Or when you are talking about the GPS system, you are going to use the geo satellites. Or you are taking for the weather, you are also taking the particular geosynchronous satellites. So as per the purpose of the satellite, you are going to allocate the orbit. In that particular part, you also have to manage the traffic in the space, so that that particular position of the satellite in the orbit can be identified, so there may be not a collision with the another objects in the present in the space. Then the development time. In the particular satellite communication field, it is very much required to generate or create that particular satellite communication system in a predefined time. Because if you are taking so much time to develop a satellite and its launching, it will create a very, you can say that easily, that if that time has been passed, the utilization is also gone. It means if you are not preparing that particular satellite system in a particular time, it is not going to be used for any type of purpose. So that's why development time is also very restricted for this satellite life cycle. Then the next point is standard launching procedure. Basically, standard launching procedure in India, we are using PSLV and GSLV, that is Polar Satellite Launch Vehicle, and Geo Satellite Launch Vehicle. Basically, these both PSLV and GSLV are used for the launching of the satellite into the outer space into the orbit, and that is a very specific procedure which we are going to study in the unit 5. Then the monitoring and tracking. After the launching of the satellite, you required a specific kind of monitoring and tracking systems, and that are basically known as TTC, telemetry, tracking and command system, that are going to monitor the health of the satellite all the time when it is in the working condition. Then the last point of the satellite life cycle, as I already told you, replacement of the satellite after its life. It means if you are using a particular satellite for a particular system, as you are using it for a particular you can say that geosynchronous satellite or geostationary satellite for the Navik, then you have to replace that particular satellite after a time, because every satellite have its own life, and after that life you have to replace that for the proper functioning of the system. So this is also a very important part of the complete satellite life cycle. So in this complete process, you can see that the traffic management is also a very important topic that is part of your syllabus, and which is come from the space debris. Actually, that is the space, about the space debris. When you are launching any satellite into the space, that will create a outer structure in the outer atmosphere, and there is not any type of procedure in which you are not taking back the satellites on the earth back after its utilization or after the satellite life is over. So this will create a continuous increment in the garbage or the junk in the outer space of the earth atmosphere, and basically that complete garbage or that particular remaining part of the satellites or the launching vehicles or the rocket boosters, that all are known as basically space debris. So when we are talking about the specific point, from the starting of the space age in 1957, about 5,560 excluding failures rockets have been launched for the satellites, out of which number of satellites these rocket launches have placed into earth orbit around 9600, and right now around 5500 satellites are still in the space, and these out of 5500 satellites, only 2300 satellites as on 1st April 2020, that number is 2666, that is still functioning satellite in the outer space. It means remaining satellites around 2000 that are not in use, but they are orbiting in the outer space. And when they are orbiting, it means they are creating a hazard for the existing working satellites in the space. So, a space surveillance network is designed by the NASA, and they are basically actually tracking and maintaining the data and catalog of that debris, and they give us a specific amount that about 22,300 objects are nearly rotating in the outer space as a debris. So, this is the current, you can take a more clear picture of the satellite communication, the satellite space debris situation in the outer space. You can see that in the outer satellite, as on the 2020, the data is given by the Statistica that USA have 1308 satellite in the space, China 356, multinational, European Union, you can say that 177, Russia 167, United Kingdom 130, Japan 78, India 58 and Canada 39. These figures are on the 2020, April 2020. After that it is still increasing, but these all basic satellites are going to create the near future debris. So, basically the current scenario of the space debris in the earth, and that particular scenario is very much important for the satellite life cycle, because for any type of satellite project or satellite communication project, the very first requirement is traffic management, and it is becoming more crucial and crucial day by day, because the number of debris object estimated by the statistical model in the orbit is around 34,000 objects are greater than size of 10 centimeter. 9 lakh objects from greater than 1 centimeter to 10 centimeter, and 128 million objects from greater than 1 mm to 1 centimeter. If you can easily understand that a 1 centimeter by 1 centimeter by 1 centimeter size of space debris can ruin a complete satellite in just a fraction of the time if they are going to collide. So, that's why this traffic management is very important. So, basically, whenever you are talking about any type of space communication or designing any satellite life phases or satellite life cycle, you have to identify the space traffic management first, so that you can easily locate the orbit of the satellite, the position of the satellite with the proper traffic management, so then maximum number of collision can be avoided. So, basically this is about the whole first unit of this satellite communication. So, before ending this, I am going to give you a complete summary of first unit. We started this by the type of satellite, that what is satellite is basically satellite is a object rotating about any bigger object in the outer sphere due to the gravitational force of that object. Then we talk about the SATCOM, that was stand for the satellite communication, as I told you, uplink and downlink frequency. Then we talk about the various types of satellites. When we talking about the types of satellites, that is as per the utilization and as per the orbit or as per the inclination. Then we are talking about the services of satellite offered by the satellite, and the last one was the frequency allocation, that was as per the LSC for the domestic, X for the military, and KU, K and KA for the extraterrestrial purpose. So, you can easily summarize this complete particular unit by these points, and in the next lecture we are going to start the second unit, in which we are going to discuss about the orbital mechanics. Thank you. Jai Hind.